extracting the data set. Now we are going to implement it in our model also, that how we can create a machine learning model and check the score by using k-fold technique. Okay, so let me share my screen first. Is it visible? Okay, very good. Now, so let me open my bamboo paper and my Jupyter notebook. K-fold technique is clear to you or not? This technique is clear to you or not? Because only you are in the class. Okay. Now let's use the same thing in our model also. See, the problem with K-fold technique, no, if we are going to use K-fold technique directly in our machine learning model, it could be a kind of tedious task. Why? Because when we are going to use the k-fold technique, no, like we need to split the data first, and one by one we need to train the model and test the model. Okay, so that becomes a tedious task. So to use it, to simplify it, we are using a cross validation. Okay, to simplify it, we are using cross validation. Okay, now what is cross validation? Cross validation is a technique. Internally, you are using k-fold technique. Okay, and then after that, basically internally, all these things done by this cross validation. You just need to give the number of k value. Only k value you need to give here. And then all that thing done by the cross validation. That means it is splits the data into k number, okay, k groups, and then train and test the model by themselves. Okay, you just need to give the algorithm which you want to use to create the model. So directly internet will do the same thing directly. Okay, and give you the score of the model. Let's see how exactly it works in our machine learning model also. Okay, so first of all, let me show you how a cross validation works. Because as you can see in K4 technique, every time you are getting S1, S2, and S3, no, and up to Sn, it is nothing but because we are using K equals to 3. Okay, when K equals to 3, it is splits the data into 3 equal parts. Okay, we discussed that thing in our last class also. It doesn't matter if the data is not, if the number of data is suppose 10. So it is not possible to split it into 3 equal parts. So that is totally fine. No need to worry about that. It splits the data into 3 parts. And then in step 1, this part as a testing data, rest of the 2 parts is not a training part. In step 2, and obviously if you're using training and testing data, it will give you some score. Then this part becomes the testing part, and both of these parts become like A and C becomes the training part. You will get the score as 2. And then at the last step, this data, this part, C part becomes the testing data, and A and B become the training data, and then you get the S3, that means score 3. And then to get the average score, you can use here the mean value S1 plus S2 plus S3 by 3. So all these things are done by cross validation now. By using k-fold, we can only split the data into training and testing one by one, step by step. But by using cross validation, we can get the scoring as well. Let's see how we can use this. So for that, I need to open my file as well. That same k-fold data here, k-fold. In the same file, I'm going to open it. Let me open my command prompt. Let's open Jupyter Notebook. Okay, so as of now, we have done with the k-fold technique. Now let's talk about cross validation technique. Cross validation. Now, so in cross validation, first of all, what we need to do, what data we want to define here, let's talk about that. So in cross validation, we need to create a model now. First of all, we need a data first of all. So the data I'm going to use is the same iris data set, okay? So let me load because they're already friendly with the data. So let me load it. So I just want to show you how it is exactly works. Okay. Uh, Data sets. I just want to import iris data set. So load iris. Okay. Okay. Or not. Load iris and then I equals to an object of it. And then in directory, you can check all these things. So in X, I can store I dot data, and Y, I can store I dot target, the independent and dependent variable. Okay, now I want to create a machine learning model. So this and check the score of the model. So now I don't need to like, we already discussed the visualization of the data. So I'm skipping that part. Now we need to split data into training and testing part to check the score of the model also, no? So for that, we don't need to apply this step here. Directly, we can do all these things. So first of all, what you need to do, you need to define here. See, in X, we can check the number of data. So we have total number of 150 number of rows and 4 columns are there, no? So here, I'm using which algorithm you want to use to create the model. So I suppose I want to use your support vector classifier or logistic, any algorithm you can take. I'm going to use your support vector classifier, okay? So from sklearn dot support vector machine. I just want to import here support vector classifier. Import. Okay. And then I need to use here k-fold cross validation also. So I can say here, again, we don't need to do it manually. We can say from sklearn dot inside model selection. I just want to use here cross validation. So cross validation. I want to check the score as well. So cross validation score. Okay. Okay. So this one is the problem. Okay. Now what you need to do, just copy this one from here, Control C and V. Now here you need to put the estimator. Estimator is which algorithm you want to use to check to create your model. Okay. And after that, the value of X and Y, and then the value of CV. CV means cross validation. In CV, you need to give the value of K. Internally, K fold is working here. Let me show you. So in CV, you can see by default the value, none means by default the value is K 5 folds. That means K value is 5 here. So let me show you how we can use. First of all, the estimator. I want to use here support vector classifier. So SVC. The value of X and Y. So X and Y, independent dependent variable. That's it. That is what. Now you don't need to split it into different way and then use the model here directly. You can do it. Okay. Let's run this code. And now by default, the K value is 5 here. Let me use here CV equals to 3. Suppose I want to split this data into 3 equal parts. So what will happen? So total we have 150 number of data. It is split the data into 3 equal parts. Okay. So the first part is of 50 data. The second part is of 50 data. And the third part is also of 50 data. Okay. Now, so in that case, what it will do, it uses the support vector classifier. It uses, first of all, in step 1, it uses this, suppose A, B, and C part. It uses B and C to train the model and then A to test the model. And you will get S1 score. In step 2, by the same algorithm, this time it uses A and C to train the model and B to test the model. And then you are getting here score 2. And then in S3, for the same algorithm, it uses A and B to train the model and C to test the model. You are getting here S3, which is the score. Okay, let's see what will the output for this one. So when I'm going to run this code, you can see S1, S2, and S3. Okay, and if you want, you can get the average value also from here. Let me know if that is clear on what exactly internally what will happen here. Is that clear? Do you understand how internally it works? Okay. Now let me use your CV equals to 5. In that case, what will happen? It is split the data into 5 equal parts. So we have 150 number of data now. It is split the data into 5 equal parts. 5 equal parts means 30, 30, 30, 30, and then 30. So at first, in step 1, this becomes the testing data, rest of the training data. And you will get S1 score. Next step, this becomes testing, rest of the data is training. Score 2. That's the way S3, S4, and 5. We got 5 S5 values here. Like a score 5 we'll get. Run this code and you can see. 1, 2, 3, 4, 5. These are the scores for this particular score, CV score. Okay, I hope cross validation is clear to everyone. You don't need to do it one by one, but directly by using cross validation score, you will understand like what is the average score of this model by using that particular technique. No? Clear everyone? Cross validation. Okay. So after cross validation, now let's talk about this is basically for checking the scores. What I want to do, it may be possible that sometimes basically what will happen now, we want to check the score of the model. Suppose support vector classifier is giving me the average of 98% accuracy. I want like I want more accurate data. In that case, what we can do, we can change the algorithm here. Maybe logistic will give me 100% accuracy, okay, or maybe k nearest neighbor give me 99% accuracy, and so on. So in that case, we are using here multiple hit and trial methods, and that works with a grid search CV. Like we can use here hyperparameter tuning. Okay, let me tell here. Let's talk about hyperparameter tuning. Now, what is hyperparameter tuning? See, which algorithm gives you the highest accuracy, or which parameter gives you the in our in our support vector machine class, no, when we are work about SVM in kernel, when we are using, no, let me show you that data. SVM kernel, this one. So when we are working with support vector machine, no, let's run this code. See, in this particular data, I'm working with a kernel. See, here you are getting 100% score. Here you are getting 100% score because the kernel is RBF. I'm changing this parameter from RBF to linear. By just changing one parameter, you can see the accuracy becomes like half. No? So this is how the parameter works in a method. Internally, all these things are the method, no, and these are the default parameters, nothing else. These are the default parameter of a function. So what parameter is good for which kind of data, that we need to understand, and that we are doing in hyperparameter tuning. Suppose if we don't know that in this particular data, which kernel is suitable for this particular data, either linear or RBF. So we need to hit and trial this. No, suppose if we don't know anything about kernels, if we don't know anything about that method, it is not possible to have knowledge of all of the methods. No, in that case, we can apply here hyperparameter tuning. Okay. So basically in hyperparameter tuning, we are just using hidden trial method to get which parameter is best for my model to get the highest accuracy. Okay, just like here I'm using linear, so it will give you 50% accuracy. And if I'm using your RB, by just changing one parameter, I'm getting the 100% accuracy. Same way, here also I want to check which parameter is good for my data. Okay, so basically in hyperparameter tuning, we have two things: grid search CV and randomized search CV. We are going to work on grid search CV. Okay, so let's see how we can apply grid search. And here CV means cross validation, nothing else. Internally, now you don't need to use your train test split method directly. You can use cross validation. Just give the number of splitting and then you are good to go. So let's see how we can apply it. So in that case, we need to import it first. So I'm using it from sklearn dot model selection. I want to import here grid search CV. That's it. Now, create a model of it. Model equals to grid search CV. Now, what parameters we can put here? First of all, the estimator. Estimator means which algorithm you want to put. So suppose any, because we imported support vector classifier now, so we can use support vector classifier or any other algorithm you can use. What parameter you want to use for the estimator? The scoring value, lots of things are there, the CV value. Okay, all the things are already mentioned over there. Okay, so I'm only going to use here the parameter estimator, parameter grid, and the CV value. The estimator I'm going to use here is support vector classifier. Okay, so SVC, this is my estimator, and then the parameter grid. So parameter grid is equals to, I'm using here. See, in support vector classifier, we have lots of parameters are there. We have C value, we have kernel value, we have degree, gamma, coefficient, shrinking, probability, lots of things are there. Okay, so what we can do, you can see here. See, suppose if we have no idea about what exactly the C parameter, okay, so in that case, you can see float default is equals to 1.0. Regularization parameter, it is used, but like here we can only put the float value. Okay, in kernel we have these 5 values are there which we can use for kernel. Okay, then we have degree value, it can be always be in integer, and the default value for degree is 3 by default. Gamma value is either scale or auto, and so on, lots of things are there. Okay, so first of all, I'm using as a C value, as you can see. Let's copy it. So C value. Okay, Control V. Oops. So by default, the value of C is 1.0. Okay, what will happen if I'm using a 3 or 5 or 2 or 7? Let's see. So let's use here, by default is 1. I'm using here 2 and 5 also. Okay, so it uses basically permutation and combination internally to use each and every parameters one by one and check for which parameter my model is doing correct accuracy. Okay, then after C value, let me use your kernel also. So the kernel parameter in kernel by default is RBF. Let's use your linear. Linear and let's use RBF as well. Let me use only these 2 parameters from here. Okay, now again you can use other parameters as well. I'm just to simplify it, I'm just using 2 parameters from here. Now after that we need to use a C value. So CV equals to, let's use here 3. Okay, 3 means I want to split that data set into 3 equal parts. Okay, now so okay, comma. Okay, let me know everyone if this part is clear to everyone. Do you understand what I have written over there? Each and everyone, let me know whether this line is clear to everyone or not. Yes, let me repeat it one more time. So basically what we are doing here now, see, in grid search CV, no, you can see we are doing here hyperparameter tuning. Hyperparameter tuning means which parameter is good for my data. Okay, so if for my iris dataset I'm going to do here, okay, but the parameter I'm defining it first. So I'm not giving here any X and Y value. First of all, I'm just using my estimator, which algorithm I want to use first of all. So estimator means which algorithm you want to use in your model. I want to use your support vector classifier for my iris dataset. Now the parameter grid of that particular algorithm. So you can see in support vector classifier, we have multiple parameters are there from here. Okay, we have multiple parameters are there. Now, by default, we have some values like C equals to 1.0, kernel equals to RBF, degree equals to 3, gamma equals to scale, and so on. But how we know that which parameter is good for my data? Okay, suppose if you already know about the answer, if you already know, if you know each and everything about the support vector classifier, you can understand what a value is good for my data. But what if we don't know anything about that algorithm? In that case, we are using hyperparameter tuning. Okay, that the C value is 1.0. What other value can be for C? So the C can always be in float data. Okay, so by default, the value of C is 1.0. I'm using here C equals to, I'm using a C equals to 1, 2, and 5. Let's check what is the accuracy when C equals to 1, what will be the accuracy when C equals to 2, and what will be the accuracy when C equals to 5. I'm just using some random value only just to check because it uses combination and permutation and combination. So at first, it checks C equals to 1. At second moment, it checks C equals to 2. And at third moment, it checks C equals to 5. Okay, and give you the accurate answer. Which accuracy is good for our C equals to 1, 2, or 5. Same way, we have more parameter, any number of parameter you can give here, okay? Now, the second parameter here is kernel. By default, the kernel value is RBF, okay? What other value can be for kernel? So, the kernel can be linear or polynomial or RBF or sigmoid or pre-computed. By default, the value of kernel is RBF. So, let's see what will happen if the kernel value is linear and RBF or polynomial or any other value here. So, I'm just using here 3 of them. If you want, you can use all of them or any of them. Okay, so I'm using here these two. Same way, you can apply here more parameter grids also. Like we have a degree value. So degree value can always be in integer. You can see. So default is 3. Let's check 1, 3, 5, 7, 9, any other value to check. Okay, now lots of other things are there you can check. And then at last, I'm using a CV equals to 3. So for training and testing part, no, I want to split it into 3 equal parts. Okay, is that clear now? Soham, let me know. Now, let me tell you how exactly it works. Okay, so first of all, it uses support vector class. Now, before that, we are using here SV equals to 3. So let me use that iris data set. So here we have 150 number of data now. So first of all, it is split into 3 equal parts like 50, 50, and 50. These are the equal parts 1, 2, and 3. Okay, now in that case, the parameter grid are C and kernel. So in C, we have 1, 2, and 5. In kernel, we have linear and RBF. So you want to create a machine learning model here by using support vector classifier. Okay, so at first, it takes all the default parameter will remain same, but C value at first becomes 1 and the kernel value first of all becomes L. Okay, rest of the parameters become same. Okay, that remains same. Now, at first it uses this data as testing in step 1 and these two data as training. Okay, when C equals to 1 and K equals to L. Okay, and you are getting S1 score. Okay, then C equals to 1 and K equals to R this time. It uses permutation and combination. So each of the combination is going to check again for the same type of data. Okay, in the same case, it uses C equals to 1, okay, and then K equals to R, S2. Basically, by default, check 3 times, okay, for each of the data, for each of the parameters here. Okay, again, C equals to 2, K equals to L, C equals to 2, K equals to R, and then C equals to 5, K equals to L, C equals to 5, K equals to R. These are the combination it is going to use to create the machine learning model. Okay, now me show you here. So my parameters are done. Now let's fit the model. So I'm using my X and Y value here, the whole value. And you can see the parameters here. Now let's check the score value. So first of all, I want to check the CV results, the cross validation result I want to check. And you can see here, this is the output. See. Now, what is the meaning of all these lines? Let's talk about that. First of all, you can see the parameter here. C equals to 1, kernel equal to linear. C equal to 1, kernel is RBF. C2, kernel linear. C2, RBF. C5 linear, C5, RBF. This is the parameter. Permutation combination. In split 1, 2, 3. because CV equals to 3 we have. So split 0, 1, 2 it uses. Okay, in split 1 we have this particular accuracy, because we have 1, 2, 3, 4, 5, 6 number of combination here, no? So that is why each of the combination is split 0. We have this much of data. That means when C equals to 1, K equals to linear, the accuracy is 100%. When C equals to 1, K equals to RBF, the accuracy is this. When C equals to 2, kernel equal to linear, the accuracy is this, and so on. Then again, in split 1, again it will check the same thing, and in split 3, it again check the same thing. Okay, but the training and testing data becomes change. Okay, now then you can see the mean fit time. It will give the, for fitting the model by the data, it chooses the fit time also. This will become the fit time 1, 2, 3, 4, 5, 6. Okay, why 6 time only? Because the splitting is, the combination is for 6 times. Okay, now standard fit time is this, mean score time is this, all these things are here. The parameter C is 112255. The parameter kernel is linear RBF, linear RBF. This is nothing but this one. At first C equals to 1, kernel linear, C1, kernel C112255, linear RBF, linear RBF, linear RBF. All these things are defined here. Okay, and then it will give you the output. But we don't need all these values. What exactly we want? I just want to know for which parameter out of all these things, which parameter is good for my that data. So I'm using here model dot best score I want to check. So the best score is 99% accurate. And let me check which parameter is good for the model. So the best parameter I can check here is C equals to 1 and kernel equals to linear. That is the best parameter for this data. Okay. Let me know if that is clear to each and everyone. That how we can do hyperparameter tuning. You need to do some practice for that. Okay. And you will be able to do this. Is that clear, everyone? Let me know. Okay. Any query as of 91? Cross validation and hyperparameter tuning is clear? Cross validation and hyperparameter tuning is clear, everyone? Okay, so now let's see, after creating all these machine learning models, now let's talk about how a user can use it, because we just don't want to create a model. What we want that the user, the public also use that model actually, no? So in that case, what we can do, we can deploy our model. So let's see how we can deploy our own machine learning model. Okay, so that everyone can use it. Okay, not only we can use it, but everyone can also use it. Okay, so for that, I'm going to create a folder here for deploying my machine learning model. I'm giving you the example for the very simplest one, and then you can apply it in any of the data set. Okay, so let me close all these things from here, and let's see how we can deploy a machine learning model. And I'm going to see, basically we have lots of techniques are there. You can use your Flask, you can use Django, we can use here any other thing, but I'm going to use here Streamlit, library of Python programming to deploy a machine learning model. Okay, so for that, I'm going to open a folder here for deployment of machine learning model. So model deploy. Okay, and here I'm open my Jupyter notebook. Okay, and then open as Jupyter notebook. First of all, which machine learning model I want to deploy? So I'm going to use that same area price prediction. Okay, so we need the data first. So let me upload the data here. So we can do it like this also. That data I want to use, areas, control C and V. Okay, that data I want to use. Let's rename it. Area price prediction. Okay, and model deployment. Okay. So let's see how we can do this. Lots of things are exactly same. Only one file will be different. I'm saying that if you're going to create a machine, when you're going to deploy a machine learning model, no, always try to deploy the model in a separate folder. Okay, that will be beneficial for you. You will understand why I'm telling you this thing. Okay. So first of all, let's access the data first. So that is a CSV data. So I'm going to import pandas first to access the data here. And then df equals to pd dot reads, just a minute everyone. Okay, so pd dot read CSV and that area price prediction, area price 071.csv. This is the data frame. So what exactly I want to do, we discussed the data already. The first machine learning model is on the same actually. So we want to get a machine learning model where I want to input the area and that will predict the price. The model predict the price, but not in the by using the model. Now I want to convert that model into a web page. So in a web page, I want to create a text box and I want to create a button here. So everyone can just input the area here, and whenever I'm going to click on this button, it will predict the price of that particular area. That is what I'm going to create, okay, by using Streamlit. So let's see now. So first of all, what we need to do, I want to split the data into independent dependent variables. So I'm using a x equals to df area and then y equals to df dot price. Okay, after splitting the data, now what we need to do, I'm not checking the score and all, I just want to show you the deployment process only. So let's import that algorithm which we want to use. So I'm going to use a linear regression. So from sklearn dot linear model, I just want to import linear regression. So it's n. I just want to import here linear model, linear regression. Okay, create an object of it, control C, model equals to V. Okay, and then let's fit the model. So model dot fit function, your x and y, and then let's do some prediction also. So model dot predict when this is like a area is 345, so the price is this. Let me ignore that warning as well. So import warnings and then warnings dot filter warnings, and let's ignore it. Okay, now, so as of now, things are done. Now I want to deploy this model. So to deploy this model, what I'm going to do, basically, I'm going to use a Python programming to deploy my, and that library I want to use here is Streamlit. Okay, so basically, what exactly, I don't want all these things from here. I don't want from the first line to the last. I don't want all these things from here. I just want the trained model, not all that thing which used to create that model actually. I just want this fit model. That's it, by which we can predict anything. So in that case, what we need to do, we need to basically convert that model into an object file so that we can use it. Basically, what we want to do now, I have that model created here. I have a trained model. I want to use it in different platforms, or I want to use some other where, some other place actually. So in that case, what we need to do, we need to convert it into object files. In Python, we can say, I need to convert into pickle file. Like suppose a kind of, you can say, more portable I want to use it, no? So that because it is a very big file, no, the train model I want to use here. So in that case, what we need to do, we need to get a pickled file. It is a kind of serialization and deserialization kind of process I'm going to do. So I want to convert that. Suppose if I have multiple vegetables here, lots of vegetables are there, and I want to, when I'm going to convert all these into a pickle format, so it becomes in a jar only. Okay, and it will take very less amount of time here, less amount of memory here, no? So in that case, and if you want to enjoy it, just get it from the jar and have it, no? The same thing we are going to do here also. So we need to if we want to use that machine learning model in other files also, we need to convert into pickle files. Serialization I want to do for the data, which we're doing in Java. Okay, so let's convert that data in pickle files. Okay, so like I want to convert into object files actually. So for pickle file, we don't need to do anything from the scratch. Directly we can import pickle model. It is already available in Python actually. So let's import it first. So import pickle. Okay, and then if you are unable to import it, no, you need to install it first. So you can use your pip install pickle. This is how you can install pickle in your system. Okay, and then import it, and after importing pickle, we can just convert that whole model into a pickle file, into an object file. Okay, so let's see how we can convert it. First of all, in pickle, no, we have two options are there: loading a data and dumping a data. Okay, or you can say loading a file and dumping a file. So here what we need to do, let's see. First of all, what we want to do, I need to convert the data into pickle file. So we need to dump it. Okay, I need to dump all this whole model into a pickle file. So we can do it like this. Here basically we are using actually file handling. If you remember file handling thing we discussed in Python programming. So I'm using here pickle dot, the function is dump. I want to dump a file from normal file to an object file. Now, which file you want to convert, what thing you want to convert into pickle file? I want to convert this model into pickle file. So the name of the thing, model, I want to convert. I want to convert into a pickle file. So to create a file, we need file handling. So I'm using your open. What file you want to create? A pickle file. So area price dot pickle, any name you can put for this particular file. And because I'm not using the path, that means I want to create the file into current working directory. And then because I want to create the file, that file is also a like object file, so we can use your WB. If the file is not in object file, then we can directly use W model. Okay, let's run this code. Nothing happened. Basically, what will happen now? They're using, it creates a area price.pickle file my current working directory. Let me show you. So here you can see model deployment. Here you can see now at few seconds ago, you can see area price pickle file is created here. Now this file is basically our model. Okay, if you want to use a model in any other file, you can directly use it, load it, and directly use it. It is a pickled file of the data. Now let's see how. Now there is no need of this file now. There is no need of this file now. We just need this pickle file only. Okay, because in this file, in this pickle file only, we have that trained model. Okay, so now we need a Python file now. Either you can open it ideally, or let's do it here. Let me create a Python file here. Let's save it as a my file.py. Okay, let's write the coding for deploying the model. First of all, we need that data first. No, we need that data first here. So import pickle, and then load the and then because I want to use Streamlit, no, so I need to import a Streamlit. So import Streamlit. Okay, as any alias name you can take because the name is very big. So I'm using an ST or STRM, any other name you can take. Any name you can take actually. It is just for a shortcut name, no? Now I need to load that data here, load that model here. So I'm using your model one equals to any other name you can take. I'm using a model name, model one here, because I want to import, I want to access that model data here. So pickle dot load. I want to load that data. Okay, load. I want to load that pickle file here. So I'm using here open file handling or process I'm using here. Okay, which file? Area price dot pkl file. Okay, and I want to read that file. So read B, like a read binary. That's it. This is how you can access the data from here. Okay. Now model one, in model one variable, no, we have, it converts into a, basically the model file. It becomes a trained model now because we imported here. Now let's use it. So I'm going to create a function here to create a model. So I'm using a def my deploy, any other name you can take. And let's see. So strm dot, first of all, I want to make a title of my web page. Title of my web page, no, title of my, basically the title of my model actually. So I'm using here, it is for area price prediction. Okay, now after that, we need to take a value. I need to take a text box, no, to take a value from user. So I'm using here area equals to any name you can take. Okay, I'm using an area equals to streamlit dot. We have a function called text input by which you can take a value from user in streamlit. So text input. Okay, and if you want, you can write some value over here, some message here. So I want to use it here, input area, or enter your area here. That's it. Now let's create a button also so that everyone can click it and get the prediction from there. So I'm using here prediction equals to pred equals to, I'm using here stream dot button. Okay, and I want to write inside the button is predict. Any other thing you can write here. That's it. Now, if someone press on that button, I want to define the prediction part. So I'm using here if anyone press spread button. So just write here model one dot predict the value of area. Okay, but the problem is in the value of area, we need a two-dimensional data. No, because a model is trained with the two-dimensional data. So I'm using here two brackets for the value of area. That's it. And then let's write the value in the output screen. So I'm using a stream dot write, and then price of the area is the value of, let me store it into a variable called a, is the value of it. Let's see how exactly it works. Okay, let's see. Okay, so first of all, it will not work until we are not going to call this function, no. So let's call the function my deploy. Now how we can run this code, let's save it first of all. How we can run this code? So for that, we need to open our command prompt here. See, I have this my file. Okay, that Python file. If you want, you can open it like this also in ideally. Okay, let's open that file. Let me open my command prompt. And how we can run this file, let's see. So we just need that my file only now. So I'm using here streamlit run my file dot py. That's it. You will get a URL here, a local host URL here. See, it will open a web page. Area, this is the title. Enter area. Here we can write the area. So I'm writing here, what if the area is this? When let me put the prediction here. The prediction is price of the area is this, but it is in a kind of two-dimensional data. I just want this value, not all these box from here. So in that case, the 0th number of data I want to access. So we can do it. We need to make some changes here. So here I can say A of 0. That's it. That is what you need to do. Save it. Run this code one more time. Let's open. Let's refresh it actually. area is this and the prediction is this. Now the price of that area is this one. Let me know if this whole the process clear to everyone or not. Do you understand how we can deploy our model? Now everyone can put the area value of area and predict the price of the area by the model. Okay, now no one can see the coding part. Okay, all these things are abstract now. Is that clear, everyone? Let me know how we can deploy a machine learning model. Okay, so if that is clear, now let me show you the syllabus part. What else we have here? So give me a second, everyone. Just a minute. First of all, let me know, everyone, whether session 1 and session 2 is completed or not. Session 1 and session 2 is completed or not. Each and every topic. If you have any other syllabus, no, then you can just send me in the chat box. I can check it also. Okay. What about session 3 and 4? What about session 3 and 4? Okay. Session 5 and 6? Session 5 and 6, working with NumPy array and data pandas actually. Okay. What about session 7? 7 and 8 actually. Session 7 and 8. Okay. What about session 9, everyone? 9 and 10 actually. Session 9. Regression, simple and multilinear regression, classification, binary and multi-class classification, support vector machine and KNN. And what about session 10? Salary prediction, house price prediction. Have you worked on all these dataset or not? Iris dataset, MNIST, Titanic, and Cephar. All these dataset, all these courses are compared or not, everyone? For the data science subject only. For data science and machine learning, all the syllabus is completed or not, everyone? Okay. Now, the next thing is after, because the syllabus is completed, now what you need to do? Again, you need to create a project. Okay. Everyone needs to create a project. Okay. So, suppose if you are creating a machine learning, so basically in the project, you will get this kind of mail in your email. Let me show you. One. So this kind of project report mail you are getting over there, maybe in few days you will get it. What exactly you need to do? You need to create a machine learning model and deploy it. If possible, try to deploy it also. Okay. And if you're from a specialization course, then you need to deploy the model. Okay. If you're not from a specialization course, if you're only from for the Python machine learning course or only for the data science course, you can skip the deployment part, but it is good to deploy the model. Okay, so basically what you need to do, you need to choose any of the topic. Any topic you can choose as per your interest. Any topic you can choose to create a machine learning model, okay, as per your interest. Okay, and after that, after choosing the topic, you need to create a project on it. Okay, the prediction model you need to create, and then you need to basically all these steps you need to perform there, okay, by creating a machine learning model. Okay, and then you need to define that what will happen, like what is the, what, suppose if I'm going to predict the monsoon, like at this date this will be the monsoon prediction if I'm creating. So what will happen, suppose if you're creating the model for your company, so how, what is the use of, what is the pros and cons of that machine learning model, what you are going to solve with that particular model, that you need to discuss, that you need to define in the report. Okay, all these things you need to explain. Okay, so after creating the machine learning model, after defining all these things, now you need to create a report also. Okay, after creating the model, you need to create a report. Now what exactly the report looks like, we'll show you the demo also, that how a report looks like. Now, so basically after creating the project report, you need to create in the report part, the report is only going to be submitted. So in the report part, the first page is a cover page in which you need to specify the project title. It can be any title, and the project title you can choose by yourself as per your interest. Again, I'm saying you can use your project title, the project, person submitting to and by. Okay, now for that you can refer below, like the report must be referred to these two persons and need to be mentioned on cover page of report 1 of the report. For all students, you need to mention, just copy it from here, Mr. Mayur Desevak. All these things you need to copy and paste on the cover page, and your subject trainer. So because you are doing here machine learning or data science or course, so just copy this thing from here and paste it in your project report front page. Then you need to mention a content table, like index kind of page you need to create, where you need to mention the serial number, title, and the page number. And then list of the figure, if you're using any figure, list of the figure you need to mention, list of the table you need to mention if you're using any special kind of notation if you're using in your project, mention it. Abstract of the project you need to write, the summary of the project you need to write, objective of project, like from where you get the motivation to create that project, the plan of research, the methodology, the introduction, the preamble, all these things you need to mention in the objective of the project. And then detailed process of the project development, the system requirement if any for the project, the DFD diagram, all the algorithm of the or the algorithm of the project, input and output screenshots, image or video if you are using any. Okay, and then the coding part, you need to mention the screenshot of the coding. And then if you're getting, and if you're doing getting any references from the internet, just mention all these things. For report formatting, you need to apply this thing. The font size should always be Calibri or related. Like basically, you don't need to use any stylish kind of font type. Always use that kind of font type that is visible, that is clearly visible to each and everyone. So use a simple kind of font type like Calibri or Times New Roman kind of thing. Font size should always be 12 for normal text, 14 for heading, 16 for major headings, and 10 for figure caption. Font color should always be in black or shade of black, which looks formal. Actually, don't use red, green, blue kind of color in your project report. The page size should always be in A4. Orientation should be portrait, and the file type, we need to create the report into docs and convert into PDF to submit it. Okay. Now you need to mention the logo of the company also. So the official logo you will get from here. You need to follow our LinkedIn page also, so that after the completion of the project, after completion of the certification, basically, if you are placing somewhere, so we are getting some calls whether this person is done submission or over there or not, like all this information they're getting, they're contacting for us actually. So if you are connected with us, that we can contact with you and any other kind of help if you are wanting over there. So for that, follow our page over there. Then if you want any other information about us, just click on it to get all the information about us. Okay, now there is only one way to submit the project report, and that is by clicking on that link. So click here to submit it. We don't mail anyone, like or me or any other one, to submit the project report. Only one way to submit the project report, by clicking this link. Whenever you're going to click on that link, you will get a Google form. Here you need to mention your name, your college name, your email address, your project title. Suppose you're getting a project title for mobile price prediction, so put it here, mobile price prediction. Then your phone number, your online internship subject. Suppose uh if you are doing a course of data science specialization, okay, that is a 4-month course or 3-month course. So in that case, you need to choose the subject here, data science and machine learning, or not the specialization. Why? Because now you are doing data science and machine learning. For that, basically in specialization course, you need to create 4 projects actually. So one by one, at first you chooses the Python programming, then machine learning or data science actually, then Tableau, and then this other part, then the final project actually. So here, and if you're from a Python plus machine learning course, so you need to mention your data science only, because Python project you already submitted. Now that is a project of data science and machine learning. Okay. Now, then after that, the duration of the project, the duration of the course you are doing, the project report you need to mention here, the project report you need to upload here. Okay. And you can see here, it must not exceed 10 MB. So the file must not exceed in 10 MB and always be in PDF format only. Okay. Now, here you need to follow our LinkedIn profile, take a screenshot and upload it here. And then if you are a working professional or in a school or in a college, you need to mention your, if you're in a college, you need to mention your training and placement officer name. If you're in a school, you need to mention your principal name here. And if you're in a working professional, you need to mention your team manager name here. Then the person's phone number and the email address over here. And then submit, click on submit to submit the project report. This is the only process to submit the project report. Okay. Now we have some other notification also here. The instructions are also here. That is, the size of project report must not exceed 10 MB and need to be in PDF format only. Last date you will get, like in your email you will get that last date. This, you can create the project report in a group also. Okay, so you can create a group of 2 to 4 persons group, and that can be of different or same college. Okay, no foundation in it. Also, if you want, you can create the project report individually also. If you're creating the project report in a group, so on the cover page, you need to mention your group name, and all the person need to submit the project report individually. Okay. Now, we are not accepting project reports via email or as a reply of this mail or to trainer. So we would like to request you to comply the process. The process to always click on the link, submit the project report, and do this. Okay, you can expect that information is mentioned in your email actually, and lots of other informations are there. If you're having any technical query, you can just mail me or you can message me on LinkedIn. If you're having any query related to certificate or any other thing, you can click on this link. It will open a, you can raise a support ticket here. Just click here to raise a support ticket, and our company get back to you in 1 to 2 days. Okay, so this is how you can contact with us. Okay, now let me know if you're having any query. Let me show you a sample report also, so that you can get an idea about it, that how a sample report looks like. See, so try to create better than that. So project name, submitting to and by. Okay, here if you are creating the project report individually, mention your name. If you're creating the project report in group, mention all your group members. Last date for submission, you will get you will get at least 7 to 10 days of time, so no need to worry about that. You will get a mail regarding that. Okay, content table, list of the figures, abstract of the project. That is a Python project actually, project summary, but you can get an idea about like how we can create your own. Objective of project, details, project developed process, system requirement, data flow diagram, input and outputs of the project. Okay, and then the source code and the references. So this is how we can do this. Any query? Soham, do you have any query regarding project and project report? Any query as of now? Everything is clear or not to you? Okay, so if you're having any query, you can just message me on LinkedIn or just mail me. Okay, if you're having, or also I'm going to upload that sample report on the same LMS and all the notes also, that you can take a reference from there. Okay, so for now I'm going to close this session. For all the students like who are from other course, like specialization course, so for that your classes of like stats or the tableau class is going to start within like, or maybe it will take some time, like maybe after completing the project report we will start your class of stats and the tableau. Okay, so don't need to worry about that. Try to focus on your project first of all. So for now I'm going to close this session. That is your last class for data science actually. Thank you so much everyone and all the best. Ma'am, how to create in group? So just take a topic. Okay, just take a topic of the project, like any, suppose if you want to get a project topic of area price prediction. Okay, I just a random thing I'm using. So you can create a project report in a form of like a, just a minute. Okay, so we are talking about like if you want to create a project in a group, no, what you need to do actually, just take a topic, okay, and divide your things. Like anyone is going to like create a, collect the data, someone is going to like suppose like divide your task. Okay, someone is going to deploy the model, someone is going to create the model, someone is going to clean the data and all. Divide the task and do the project in a group, and then someone is going to create the report only, and so on. And then in the first fun print, what you need to do, just in submitting by, you need to mention all the group members name, and all the persons need to submit the project report individually. Suppose if in your, if you are creating a project in a group, okay, but the members of the group members should always be of the same course. Okay, in the same batch, the group members should always be in the same batch. Okay, now suppose if you have 4 group members are there, so if you're submitting, suppose your name is A. Okay, so submitting by A, B, C and D. Suppose if D is going to submit the project report, so D, B, C and A, this kind of thing. Like if you are the submit, if you are going to submit the project report, you're mentioned at the front page at the first, and then the next person name is there. Okay, do you understand this point? Is that, Soham, is that clear to you? Any other query? Okay, so for now I'm going to close this in, and for the like the data science course is completed as of now. Okay, you can check all these things. If you're having any topic like a left, like if I have not covered, as you see, like I showed all these syllabus over there, but again if you think any of the topic is not clear, then you can just let me know in the chat, in the email address, like till 12 p.m, like you can say till 12 a.m tonight, you can tell me, and everyone who is checking out the recordings also can check me if any of the topic is not completed, so that we can schedule the next class also to complete all that points also. Okay, so for now I'm going to close session. Thank you so much everyone, and good night and all the best.